being smart is a positive thing, is it not? I, I think so. Being smart is nothing to be ashamed of. My philosophy is, if you got it, flaunt it. Am I right? Is everyone here smart?
Yeah,
We're pretty smart here. I think I'm smart.
You know, in this day and age, and I emphasize in this day and age, there are people out there who claim in all seriousness that the sun revolves around the earth. Can you believe it? Well, does it? Well, if you're smart, of course you know the answer. The earth, like all the other planets, orbits the sun. Well, you. Are you smart or less than smart, or as we lovingly call it these days, intellectually challenged? Are you enlightened or ignorant? Does the Earth orbit the sun, or is it the other way around?
I'm not dumb. I'm smart. Earth goes around the sun. That's pretty obvious, isn't it? All smart people know this.
Good, good. So, what do you think of folks who disagree with you on that point?
They're ignorant. They're haters. They hate science.
Very good. You're positively brilliant.
Oh, come on. I'm not brilliant. I do know the basics, though.
So, does anyone here believe that the sun revolves around the Earth?
No, we're not dumb.
Of course not. We're smart people.
Once upon a time, there was this Greek man whose name was Aristotle. He founded the famous Lyceum. And also, among all the other things, great things that he did, he was a great thinker. He devised this system. We could call it a model. And within the boundaries of that system, the Earth was perfectly spherical and perfectly motionless. And everything else in the sky, the sun, the planets, the moon, the stars, everything revolved around the Earth. Less than a century later, another Greek man called Aristarchus devised another system or model in which the Earth revolved around the sun. No one took him very seriously because Aristotle's model worked perfectly. It was good enough for the calendar, predicting the eclipses and navigating the seas by the stars. If it ain't broken, don't fix it. About 4 centuries later, another man who was at least partly Greek, who lived in Alexandria, called Ptolemy, took Aristotle's model and threw some math at it, finally making it a full-fledged astronomical system. His numbers were relatively precise, his calculations perfect. So much so that 1,000 years later, Copernicus, while devising his model, used Ptolemy's calculations extensively. Now, Copernicus's model placed a motionless sun in the center of the universe. Now, in terms of just numbers, Ptolemy's system, Ptolemy's model, was far more precise than that of Copernicus. 100 years after that, a Danish priest, philosopher, and astronomer, Tycho Brahe, the last great astronomer not to use a telescope, devised his own system, which was kind of a compromise. All the planets in the solar system, except Earth, revolved around the sun. And then the sun and the rest of the sky, where the stars are fixed, which in the Bible is referred to as the firmament, all that revolved around a motionless Earth. Now, the biggest problem with Ptolemy's and Tycho's models was that, for instance, the orbit of Venus looked like a coiled cable, like all those loopy-loops, which made calculations very difficult. Both Johannes Kepler, who was Tycho's student, and Galileo favored simplicity in their calculations because it's easier to apply math to circles than to coiled cable. Maybe. Now, using Tycho's data, Kepler finally figured out where Copernicus had gone wrong.
Scheisse, I knew it. That Polish bungler was talking out of his ass.
The planet's orbits were not perfect circles, they were elliptical. Galileo, who was stubborn, rejected that idea outright. And when Galileo disliked something, he made it a point to make sure that the entire world knew that the idea was dumb, stupid, moronic, asinine, and so forth, and so was the idea's author. Like with the tides,
Galileo hooted at the idea that the moon might have something to do with the tides, and anyone who even remotely entertained that idea,
anyone like that was a total imbecile. There was a point where a comet, or maybe even three comets at the same time, I'm not so sure about that, were visible in the sky over Italy. As luck would have it, Galileo was sick that day, probably had the flu, so he couldn't observe them, or it, himself. But then there was a whole slew of articles in scientific journals all across Europe about the comets.
and the consensus was that these comets were some sort of celestial objects moving well beyond the moon's orbit.
So Galileo just laughed at that idea and he wrote this caustic article,
Calling everybody an idiot, as usual.
That said, he insisted that the sun was at the center of the universe. It was motionless, and all the planets, including the Earth, revolved around it, orbited it. That seemed solid enough to him.
Here's what we're going to do from now on. We're going to apply the lens of good taste to this mess. That lens works remarkably well across history, architecture, music, fashion, politics, and yes, science too. And it tends to make things a lot clearer. When you strip away the politics, the propaganda, the wishful thinking, and the unearned reverence for what's often marketed as the standard model, things begin to clear up. And not just a little bit. Not everyone appreciates that. People are often attached to the assumptions that constitute their worldview, even when good taste would suggest taking a step back.
Despite the captivating urban legend, that was not what he was put on trial for. It was a substitute charge. The original charge, which was atomism, would have resulted in torture and burning at the stake. But because Galileo had friends among the judges or friends among the judges, friends, nieces, relatives, mistresses, and so forth, he was sociable.
Go easy on Galileo, y'all.
And also because the Pope was an old friend, even though Galileo had pissed him off by calling him a moron in his book.
Whoa, shouldn't have done that.
Heliocentrism was substituted. Galileo was accused of promoting it, even though earlier he had promised not to do so. The Pope and the judges were at the same time saving Galileo from the stake and also saving face. That story about Galileo's trial is riveting, very dramatic. It has many subplots and it probably deserves another video. Please tell me in the comments below if that's the case and I'll make it. The strangest thing about it is that it's never presented in full and it's never presented truthfully. There's always an abridged version, which is normally full of half-truths and half-lies. Yet another century later, Sir Isaac Newton finally introduced some proper math to all those ideas.
Well, it was about bloody time, wasn't it? Some fish and chips, please.
And finally gave them legitimacy. You see, in science, everything fits together. Everything is interconnected.
Everything's interconnected. Everything. Oh, joy.
What Isaac Newton did was he introduced the inverse square law to the problem. If there are two cosmic objects with mass then the force of the gravitational pull on each other equals to the product of their masses divided by the distance between them squared. In other words, the more massive they are and the closer they are to one another, the greater the force pulling them together. And less massive, further apart, the force diminishes. In other words, if the orbits are elliptical, they must be following the inverse square law. And if they obey the inverse square law, they should be elliptical. The funny part about that is that Isaac Newton's idea, the inverse square law thing, also applies to Ptolemy's model and Tycho's model in equal measure. To put it another way, this is funny, the geometrical center of a model does not have to coincide with the center of mass in that model. The geometrical center of a model is whatever it's most useful and whatever it makes you happiest. That is what science tells you, and only that. Anything else is wishful thinking. The big problem with the sun being the center of the universe is that it's not. It's not even the center of the solar system, technically speaking. The center of mass of the solar system, also known as the barycenter, is sometimes inside the sun and sometimes outside of it, depending on the year. And the sun orbits it in the loopy-loop manner, coiled cable. The heliocentric model, the sun in the middle, makes life a bit easier for mathematicians, at least today, but it does have its share of problems. For instance, if you observe the Earth from, say, Mars using a telescope and an oxygen tank, you'll soon notice that the Earth's own orbit around the sun is not a circle, it's not even an ellipse. It's still a little bit of a coiled cable because of the Earth-Moon system. See, the moon, even though it's a lot smaller, it keeps pulling us now away from the sun, now towards the sun, while it's rotating around the Earth. And if you want a perfect conic section, you'd have to consider the barycenter of the Earth-Moon system. And this barycenter is inside the planet Earth, but not directly at its center. Finally, Albert Einstein came up with his own model, which is witty, which was predicted by Nicholas of Cusa, who lived before Einstein with his relativity and before Galileo with his antics, and even before Copernicus with his half-baked heliocentrism. And Nicholas said this.
1. The universe has no geometrical center. Forget about it. Vergiss es? Yeah? 2. There is no such thing in the universe as a naturally existing perfect circle. Yeah? 3. No matter where you are in the universe, you can count yourself as a motionless observer. Yeah?
Both heliocentric and geocentric models are right about some things and totally wrong about some others. And Tycho's witty compromise is just as legitimate a model as the other two. Now, considering the time, money, energy, and resources that we've invested in the heliocentric system over the centuries, it is indeed now today easier for mathematicians, astronomers, and astrophysicists to deal with. We've really built on it, and we didn't build on Tycho's or Ptolemy's models, so they fell behind through no fault of their own. That said, there is really no difference among those three, neither philosophically nor scientifically. Another fact that truly appeals to my sense of humor is that we can't really land a spaceship on the sun, much less set up a colony there. We observe the solar system from here, from the Earth. which makes all our observations necessarily geocentric. And guess what? We use the geocentric model in 99.99% of all our engineering projects. Yeah, the Earth is round, motionless, and everything else revolves around it. And this is even more hilarious. We even use the geocentric model in our space programs. So far as our engineers are concerned, the Earth is motionless and positioned in the center of the universe. We take into account neither its orbital speed nor its rotation around the axis when we're, building a bridge, designing a smartphone, working on a farm, or flying an airplane. Even when we get rockets into outer space, the beginning of the journey through the atmosphere, the calculations are based on the geocentric model, good old Ptolemy. What about GPS? Oh yeah, very much geocentric. There are relativistic Einsteinian calculations involved because those satellites, they travel high above the surface and at great speed. So the time dilation needs to be taken into consideration. They're both special relativity and general relativity are at work there, okay? Time shrinks, time expands, and we have to account for it. 38 milliseconds, I think it is. We need to correct it periodically in the atomic clocks. But in all those calculations, the reference frame, the motionless part, is the center of gravity of this planet. In other words, GPS, if it could think, it would think that, well, the planet Earth is motionless and the rest of the universe revolves around it. According to Einstein's theory, it doesn't really matter what you establish as the motionless part, the inertial frame, the reference point, as Nicholas of Cusa predicted.
No matter where you are in the universe,
you can always count yourself as a motionless observer, and everything else revolves around you, whether you are here on Earth, on Mars, or in a neighboring galaxy, or anywhere else. It's basic relativity, of which, by the way, even Galileo was marginally aware. He wrote about it. We only need to consider the heliocentric model when we're way out there in space, and even then, only just a little bit. We are geocentric by nature. To all intents and purposes, the Earth is motionless. Well, some people say, well, we can think of it as motionless, but in reality, it's moving. No, it's not. There is no such thing as absolute motion, because motion is always relative to something. Shit. Aristotle was right. So, does anyone here believe that the sun revolves around the Earth?
No, we're not dumb. Of course not. We're smart people.
Please like this video. Please subscribe to this channel. I'm Ricky Vernio, coming to you from Brooklyn, New York, and I'll see you soon.